Hello everyone, welcome to the Spin Triangle. Today I am here with the lecture 5 of mathematical physics, in which we will be discussing on a very important property of second order linear differential equation or second order non-linear differential equation. Okay, today our topic is Wronskian. Wronskian. This is a very important property. This is not a property, this is a method of checking a property. Okay, the property is called whether I'm giving an idea of what is linear and non-linear differential equation first, and then I will be moving on Wronskian. Okay, the first thing is that linear and non-linear differential equation. Linear and non-linear differential equation. What is this linear and non-linear differential equation? In I think in lecture 1 I have discussed this thing. Okay, and again I am discussing. um, okay, what is a linear differential equation? Linear differential equation means the power of dy by dx or d2y by dx, okay, or d2y by dx2. The power of this thing is 1. There will be no other terms, uh, no other thing rather than this thing, okay, rather than this one. Okay. What is non-linear differential equation? Non-linear means the differential equations having this kind of constituents, say 2, say d2y by dx2, and the power becomes 3, say these are the degrees. Okay, for linear the degree, the highest degree has to be 1. Okay, for linear the highest degree has to be 1. For non-linear it is more than 1. Okay, more than 1. This is the concept of linear and non-linear differential equation. If you have any a point to be noted, okay, that if you have any cross terms, say this is like this y dy by dx, or say y square dy by dx. Okay, therefore they will be treated as non-linear differential equation terms. Okay, non-linear, they will be treated as non-linear. Why this is non-linear? Because in this term you can easily see that y is power 1 and dy by dx is power 1. Therefore they are in a multiplicative relation. This means their power will be added. Okay, therefore the total power will be what? Power of this thing will be what? Power of this thing will be 2. Okay, this violates the linearity property. This means this becomes a non-linear term. Okay, now I am going to another fact that I am just reminding you these things. Another term is called homogeneous. Homogeneous and non-homogeneous. Homogeneous and non-homogeneous differential equation. Okay, so what is homogeneous and non-homogeneous differential equations? Say if you have a differential equation, say you have a differential equation. I have defined it earlier. Okay, if you have homogeneous will be what? If you have right hand side equals to 0, and non-homogeneous is what? If you have right hand side equals to function of x, say function of x or constant, or constants. Therefore it will be treated as non-homogeneous, and this will be homogeneous if right hand side equals to 0. Now I am moving to the main topic, which is Wronskian. Okay, let me write this thing. What is a Wronskian? Wronskian is a method. It is a method of checking whether the solutions of a differential equation are the solutions. This terms come R. Okay, this means there will be um, there will be multiple solutions. Okay, it is a method of checking whether a solution of a differential equation are linearly dependent or not. Linearly dependent or not. What is linearly dependent? Okay, linearly dependent means, say a equation. I'm not writing this thing. Okay, linearly dependent or not. So say a differential equation is given as a1x d2y by dx2 plus a2x dy by dx plus a1 okay, whatever it is, a3 x is equals to a3xy is equals to 0. Okay, this is, you can easily check this thing. This is a linear and this is a homogeneous second order differential equation. Okay, this is a homogeneous. Why homogeneous? Because there is a 0. And why linear? Because there is only the second derivative of y. This is not the cross term. Okay, this is the function of x. You should not be fumble with this thing. Okay, and this is, if there is a function of y, then it will come as a non-linear differential equation. This term is a function of x, therefore this is a linear differential equation, and also homogeneous because the right hand side is 0. Okay, I think this is okay to you. Say the differential equation has solutions. How many solutions? There will say 3 solutions: y1, y2, y3. There are how many solutions? There are 3 solutions. Okay, say linearly first of all, make how to make a Wronskian. How to make Wronskian. Wronskian is given by W. It is in determinant form. This means this determinant. Wronskian will be made by y1, y2, y3, and the first derivative of y1, this is y1 prime. Okay, y2 prime, y3 prime, and the second derivative of y1, y2, and y3. Here y1 is y's are y's. Y is the direct terms. Okay, direct terms means these are these things, the solutions, direct solutions. Okay, y primes are what? First derivative of direct terms. Okay, first derivative of y, and y double prime is what? Second derivative. Second derivative of y. This is the ultimate thing. Okay. This is the Wronskian. So if the Wronskian, after solving this, if the Wronskian W is equals to 0, therefore y1, y2 and y3 are linearly dependent. Okay, therefore y1, y2 and y3 will be linearly dependent. And if Wronskian is not equals to 0, then it will be, then y1, y2 and y3 are linearly independent. Okay, linearly independent. Okay, I think you have got this point. So by Wronskian we check the linear dependency and on the linear independency. Okay, this is all about Wronskian. If there were two solutions, which are the two solutions? Say y1 and y2. Okay, if there are two solutions, therefore Wronskian will be written as this: y1, y2, and y1 prime and y2 prime. Okay, this is set all. So I am going to the question, and in this case, linearly dependent. If Wronskian is 0 and Wronskian is not equals to 0, that linearly independent. Okay, so let's move to the question. Say I am giving a question. Say two solutions of a differential equation are given as, I am giving two solutions. In the Wronskian, you will be given two solutions. Okay, what are the first solutions? Say y1 is equals to e to the power x cos x, and y2 is equals to e to the power x sin x. These are the two differential. These are the two solution of a differential equation. The differential equation here is not mandatory a differential equation. Okay, so to check their answer, I am writing the answer. Okay, just wait. Answer. To check they are linearly independent or not. Okay, there are two solutions. You can easily see there are two solutions. There will be a 2 by 2 determinant. Okay, 2 by 2 determinant. The Wronskian will be what? y1, y2, y1 prime, y2 prime. Okay, I think this is okay to you. So first write y1 is what? E to the power x cos x. Therefore y1 prime will be what? Differentiate this thing. This will become e to the power x sin x. There will be a minus sign, and another term, a uv differential. Okay, a conventional uv differential. I think you have known about this. Okay, and plus e to the power x cos x. Differentiating this thing, we will get this. First of all, differentiate this thing by taking this as constant, and second of all, vice versa. Okay, and y2 is given as what? E to the power x sin x. Therefore, y2 prime will be what? E to the power x cos x plus e to the power x sin x. This is all, and put these things on the Wronskian. Okay. Therefore, the Wronskian will become Wronskian will be, and writing this Wronskian will be e to the power x cos x, e to the power x sin x. Here it will be minus e to the power x sin x. Okay, this is sin x plus e to the power x cos x. This is the first term of this is a 2 by 1 term, okay, and therefore 2 by 2 term will be e to the power x cos x plus e to the power x sin x. This is all, and you have to do the determinant. Okay, you have to perform this determinant. A 2 by 2 determinant is drawn by this thing. It will be e to the power x cos x times e to the power x cos x plus e to the power x sin x, okay, and minus e to the power x sin x, and this term will goes with this. Okay, this means minus e to the power x sin x plus e to the power x cos x. So multiply them. E to the power 2x cos square x plus e to the power 2x cos x sin x minus so this minus will become plus, this will become plus, I think so, e to the power 2x sin square x plus plus not minus, there will be a minus sign, minus e to the power 2x sin x cos x cos x. Therefore e to the power 2x cos x sin x will go with this term, and here remains e to the power 2x. You can take common from this, both these terms remain, okay, these are surviving terms, okay, cos square x plus sin square x. Therefore it will become e to the power 2x. E to the power 2x is not equals to 0. Therefore the solutions are linearly independent. Okay, so this is about Wronskian. Now I am going to another topic. This is called change in Wronskian. If you are asked to perform a change in Wronskian, therefore what you will do. What will come out here? Okay, let me check the England again. Okay, say a differential equation. I am writing this thing. Say a differential equation is given as a2x d2y upon dx2 plus a1x dy upon dx plus a0x y is equal to 0. You can easily check this thing out. This is a linear differential equation. Okay, this is a linear and this is a homogeneous. Okay, linear homogeneous differential. Why homogeneous? Because in the right hand side there is a 0, and why linear? Because there is no cross term or there is no higher power terms. Okay, therefore then calculate the change in Wronskian. it is written as WRONSKIAN at x equals to a x2 is equals to WRONSKIAN as x equals to x1. This is the unchanged WRONSKIAN times e to the power minus integration x1 to x2 a1x a1x is what? The coefficient of dy dx. Okay, a1x upon a2x. I think so. This is correct. I think so. Okay, dx. This is the change in WRONSKIAN. This is the changed WRONSKIAN. Let me change the ink. This is what? Changed WRONSKIAN. And this is what? This is unchanged WRONSKIAN. This is all. Now let's take a question. Question is given as, for the given differential equation, the equation is given as 2 d2y upon dx2 plus 3 dy upon dx plus 4y equals to 0. Find WRONSKIAN at x equals to 2 if WRONSKIAN at x equals to 0 is 1. This is the question. Okay, read the question carefully. That for the given differential equation, a differential equation is given to you. Okay, so what you have to do? Find the WRONSKIAN at x equals to 2. Find the WRONSKIAN at x equals to 2. You have given the WRONSKIAN at x equals to 0. This is what? 0 means the WRONSKIAN at x equals to 0. This is a change in WRONSKIAN. This means the changed WRONSKIAN or the shifted WRONSKIAN you can see here. Okay, at x equals to 2. X equals to 2. Why it is given x equals to 2? I have told you a shifting here. Okay, why it is shifted? Because you can plot this thing here. Say this is the x equals to 0 point and this is the x equals to 2 point. The initial WRONSKIAN is in this position and the final WRONSKIAN will be in this position. Okay, you can see the change. This is the just change. The change is here. Okay, and the changed WRONSKIAN. This is changed WRONSKIAN. Okay, this is changed WRONSKIAN, and this is what? This is unchanged or initial WRONSKIAN. This is initial WRONSKIAN. Therefore, what does it become? We have our direct formula. If you do not know about the formula, then you will surely not perform this thing, because most of the topics of WRONSKIAN is not carefully taken in college or universities. Okay, therefore they used to skip this thing like probability. Okay, WRONSKIAN, we have the formula. WRONSKIAN at x equals to x2 is equals to what? WRONSKIAN at x equals to x1 e to the power minus x1 to x2 a2x, I think so, by a1x. Is it correct? Let me check this thing. Sorry, there will be a1x, there will be a1 here, a2x, a1x, a2x. Okay, what is a1x here? What is a1 here? A1 is this thing. You can compare with the general formula. This means a1 is 3, and you may check this thing. Say what is a2 here? A2 is 2. Okay, up to this thing. Okay, this is okay. Therefore, WRONSKIAN at x equals to 2. This is the changed WRONSKIAN. Changed. This is changed WRONSKIAN. Will be Wronskian at x equals to 0. This is unchanged Wronskian times e to the power minus x1 to x2. What is a1 here? A1 is 3, a2 here, a2 is 2, and here it is a dx. Solve this thing. This is given to you, this is given to you in the question, that Wronskian at 0 at is equals to 1. Therefore here a 1 will come, okay? 1 e to the power minus, what is x1 here? X1 is 0, and what is x2 here? X2 is 2, because in the graph you can see this thing, okay? This is the limit, okay? These are the limit. This is x equals to 0, this is x equals to 2. Therefore 0 to 2, and there is a 3 by 2 term, 3 by 2 term, I am taking this 3 by 2 term out, and there is a minus sign, there is a dx. This means e to the power minus 3 by 2, here at dx. You can solve this thing, x will be here and put the limit. This means e to the power minus 3 by 2 is here, times 2 minus 0. This will become e to the power minus 3. This is the change in the change Wronskian. Okay, change. Okay, the new Wronskian becomes which is at x equals to 2. It becomes e to the power minus 3. I think I am correct. After this, okay, okay. I am giving some problem related to Wronskian. I am giving some problem. Homework. These are the homeworks for you. You can comment in the comment box, or you can do it your solution book. Okay. Therefore, check the solutions. Question is, check the solutions are linearly dependent or not. Okay, I am giving a pair of questions in which the solutions are given. X to the power a cos 2 log x, and the second question it is, sorry, this is not, the second solution is x to the power a sine 2 log x. This is from question 1, and the question 2 is given. There will be a 2 solution, e to the power say ax sine bx and e to the power ax cos bx. Comment on the comment box that if you are getting this problem as linearly dependent, then comment as that the question 1 has linearly dependency and the question 2 has linearly independency. Okay, please like comment. I will be checking this comment. Okay, most of the time I am skipping because I used to stay busy in my work. Okay, so um, I cannot check the comments, but I'll try to solve the problems if you are facing in from any of the lectures or from any of the concepts. Okay, so thank you. The lecture of Wronskian is up here.